Hey everyone, it's David Bombal once again coming to you from Oxford in the United Kingdom. I'm talking with Hank Preston, who's been kind enough to continue the series with me. Hank, welcome to the call.
Thanks, David. Always fun. It's a highlight of my week when we get a chance to chat for a bit. So
it's very kind of you. So Hank, I'm going to put you on the spot now. I've often heard about different products that Cisco have. SDN type products, programmability products, automation products, etc., etc. So you have like DNA, ACI, APIC-EM, all these different products. But as a network engineer, I often get questions where guys say, I'm a network engineer, I'm confused. What is what? Could you, I don't know if it's possible in a short amount of time, but kind of in this session, tell us a bit about the offerings from Cisco and kind of where they fit in.
absolutely, and I think it's a valid question to go through, and I get it quite a bit as well. Is which technology should I use today, or what technology should I look at?
Yeah.
And some people criticize Cisco because there are different platforms, that we've got Nexus and Catalyst, that there's ACI, and then there's DNA. And I think that some of the challenges that Cisco has when developing products, and not even just Cisco, every networking company and every vendor that's out there, are a couple of just truths that I think everybody kind of will agree with. Hopefully everybody will agree with. And you can be my stick on this. Tell me if you agree. Whenever confronted with a networking problem, there is probably at least 2 or 3 or 4 different ways you could solve that problem. And I would say that any one of them could be argued as the correct way to do it. Would you agree?
Yeah, it just depends on who you talk to.
Exactly.
Ask 5 engineers, you get 5 different answers, yeah.
Exactly. And just because you get 5 different answers, one engineer may think that theirs is the right way to do it. But I would say that there's probably good reasons to do anything in a different way. Routing protocols, right? I could probably hold my own in a debate on either side of any routing protocol, depending on kind of what mood I happen to be in that day. And that doesn't mean that OSPF is necessarily better for every routing question than EIGRP. And BGP fits some solutions, and other solutions, maybe it's not the right solution. And so across all of these areas, we've got lots of ways we could solve a problem. And then there's also the case that just because a solution fits one domain or area of a challenge really well, doesn't mean that product or solution is going to fit every problem and solution perfectly well. There could be reasons that it fits really well into one part of the network, but it doesn't really fit as well in another part of the network. And so these types of reasons are, I would say, at the heart of why there are different platforms within Cisco, is because if we look at the breadth of types of networks that are built, the types of challenges that organizations have, if we tried to build one product, or if anybody tried to build one product that fit every potential place out there, or every potential challenge, I don't think the product would ever come out, because you'd be constantly trying to make sure that you met all the requirements. And then it wouldn't necessarily do a great job in all the areas. It would be overloaded with features. You're a customer, you're buying this solution for this one part of your network. But that product comes with features for all of these other areas of the network. Maybe you need something to act as a campus switch and routing platform, but it also has all of these service provider and MPLS WAN features that you don't need. But because they're in the product, you're at some place, you're paying for them, the software's there, whether you're using it or not. And so I think at the heart of it, that's why we have different platforms. That's why we have products that are kind of more targeted at a data center versus at a campus. Why there's an entire product line that's kind of targeted at service provider and these very large scale style networks, because they have different requirements and challenges, and there's things that you don't need in one area versus another. And so it may sound like a really cagey marketing answer. Well, we have different problems that are solved by different products. But I really think it's the truth of the matter. I've built networks in the data center using the Nexus platform. I've built networks in the campus using Catalyst and ISR platforms. And I've had cases where I've had to do the reverse and put a Nexus in a campus or in a outside of the data center area, and then it works, but there's things that are missing that don't work exactly the same way. And so I think that's the first bit of this is when Cisco builds a product line and has them out there, there's usually a target area of the network or a target domain that is intended for that product to fit into really, really well. And it may be available and function in other areas outside of the domain, but it was kind of designed specifically with one domain in mind. And I would say if you look outside of Cisco at other vendors, you're going to see similar pieces. A vendor may build their product and their niche is in the data center only. And so that's where they're going to position their equipment. They don't tend to look at, we're not trying to bring in features for campus and we're just a data center switching company or we're just a WAN company. We're really not interested in kind of at the edge or these other areas. But Cisco's so large and we're interested in kind of networking as a whole that we have things that fit into all of these different places. So that's the first bit as to why we have so much variety. Does that make sense? Are you going to kind of throw me under the bus and say, Hank, that's just a crappy marketing answer. What's the truth?
Yeah, I'm going to say that because I'm going to say RIP version 1 is the answer to all routing issues.
Ugh. Seriously? Seriously?
Obviously, that's a really bad joke.
Yeah.
RIP is better than BGP. Obviously, if you've been drinking very heavily, it makes a lot of sense.
No, there's interesting ones to go through. Like RIP's a great example. I remember when I first started decades ago as a network engineer and studying for the CCNA and learning about dynamic routing and learning about RIP and being like, oh, this is super simple, it works, and standing it up in a lab and just being really kind of impressed with how easy it was to go through. And then having this point when I started to realize that there were these other routing protocols. And I was like, why do I need to learn OSPF? And it's because RIP doesn't scale. It doesn't fit these other areas as it goes through. And so I got really excited about OSPF.
It's my bad joke, Hank. Don't worry. You don't have to explain it.
No.
Really bad joke.
I think the truth is there, though, and it goes in. Because I've had conversations with customers or just engineers and being like, you know what? I really like the Catalyst 6500. Why do we need other platforms? And we had a lot of this when the Nexus line first came out in the data center. We had all these customers using the Catalyst 6500, which was jokingly called like the Swiss Army knife from Cisco. It fit kind of every solution. And I would say it's the direction that Cisco decided. The 6500 was super successful, and there's still tons of customers using them. They're rock solid platforms, and it's a single platform that people would use as an access switch, a distribution switch, a core switch, a data center switch. Like it could fit everywhere. But that also meant that the code base for that got so huge. There was so many features that went in. Innovation became challenging because there was all of this stuff that went through. We would add a new line card targeting at a campus, and then the MPLS features didn't work quite right because it was a campus card. It wasn't supposed to have MPLS on it. And I think Cisco learned a lot from that, and then they started to say, okay, we're going to start to kind of hone in and build products specific for different areas. And so I had lots of conversations with the customers that had 6500s in the data center that got really frustrated that we were advising them that the Nexus switches in the 5Ks and the 7Ks and today the 9Ks make sense in the data center more than the Catalyst piece because they were just comfortable with that and they liked that they had a single platform everywhere. But as some of the new data... I
just wanted to say something, Hank, to interrupt you.
Oh, yeah.
We spoke about it earlier, just to inject this. We spoke about it earlier when we were talking about the DevNet website. Mm-hmm. It's sometimes easier to start again than it is to have old stuff or let's say mature stuff and then try and change it. And I think this is another example of that. Sorry to interject.
No, it's a really good point. It's called the technical debt problem. It sometimes it does make sense to kind of, you know what, we're gonna clean slate. We've got to start over. And there's pain when you start over because sometimes there's stuff that goes away, and you end up with something that a few people really, really fell in love with, some feature or some quirk of a platform, and then when those change, they go away. I mean, I still find myself trying to type write mem on platforms that don't have that command anymore because I'm just so used to that being the way to save stuff through. But we got into a bit of a tangent on the why pieces. But I think that's why we have these different platforms. And so if we think about the ones that are out there that you mentioned, we've got Cisco Application-Centric Infrastructure, ACI, we've got DNA Center, APIC-EM, and we'll talk a bit about DNA Center and APIC-EM and how they relate in a second. We've got device level pieces, so you can work with Nexus platform. We've got the Catalyst platform, all these things that are there, XR solutions. So where do they fit? Broad strokes, DNA, the Cisco DNA architecture, and then DNA is a kind of a big name that represents things that everything from Cisco that fits kind of into the campus WAN access layer pieces. And so DNA Center is today the SDN platform, the network controller, the kind of policy-driven infrastructure component that would drive your campus, your WAN types of deployments. And that's both for wired and wireless areas. And so if you're building and designing an SDN solution for your enterprise that's going to be at your headquarters and your branch locations, you're managing your SD-WAN or your traditional WAN model, DNA Center is kind of targeted at that spot. And Cisco kind of tends to call that like enterprise networking. It's the enterprise area. It's the office space, the manufacturing floors, the wide area network that connects all these locations together. That's kind of the scope of DNA and DNA Center. DNA Center is the name for the kind of the control brain that is over all of that, and it is kind of the evolution of APIC-EM. APIC-EM was out for several years. You can still grab it, but the evolution of APIC-EM as a platform in the next releases, that's kind of what DNA Center is. And so if you're a traditional APIC-EM customer, what you're used to being inside of APIC-EM is inside of DNA Center with the additional features for some of the newer things that have been added into DNA Center. And so it's kind of the upgrade path from APIC-EM is to move people into the DNA Center as part of that evolution. Does that make sense?
No, that's good. So in other words, APIC-EM, correct me if I'm wrong, is something that I as a network engineer shouldn't spend a lot of time on. I should rather spend time learning DNA. Is that right?
I would say, so if you're starting today, I would say definitely look at DNA Center because that is the newer platform that's there. If you have APIC-EM and you've got some experience with APIC-EM, the good news is that a lot of that will translate to DNA Center. And so we still have material, we have customers that have APIC-EMs out there that haven't upgraded to DNA Center. And so we still have material that helps people understand how to work with APIC-EM both through the platform perspective, but also through its APIs. And so if you're interested in programming APIC-EM, we've got the API documentation, we've got some labs for those, but we're also moving that content and updating it for the DNA Center APIs, the DNA Center platform, bringing in some of the new features. And so to circle back to your question, I would say, yeah, if you're starting now, I would say look at the DNA Center piece, but a lot of what you've seen with APIC-EM or even some of what you'll learn with DNA Center is there from kind of the history from APIC-EM because it is this kind of product evolution spot.
That's great to know because, I mean, in the CCNA courses, Cisco still talk about APIC-EM and that's sort of the product that's taught. But, I mean, courses can never keep pace with change like this. So that's good to know. So in other words, if, like you said, just to summarize, if I'm starting today learning SDN stuff from Cisco, rather than learning APIC-EM enterprise type, if I'm in an enterprise scenario, I should concentrate on DNA. Is that correct?
It is. With the one piece that you pointed out, the certifications there's always that lag to go through because it takes a lot of effort to build the material. And so if you are studying for the CCNA, I would say go ahead, go look at the APIC-EM. It's not a waste of time because a lot of what you'll learn there will still translate to DNA Center. But if you're just learning the technology to learn it, I would say definitely explore the DNA piece.
So DNA is an enterprise, so you mentioned campus and WAN, SD-WAN type stuff. Is that right? It's like a controller.
And that's what DNA Center is it's kind of in the land of SDN. It's a network controller function. And so what a network controller does, or at least in this case what it does, is it sits on top of the physical and virtual infrastructure. So it's a platform that you deploy. DNA Center is deployed as physical appliances. So you deploy a DNA Center, you connect to DNA Center, and it discovers the network that's below it. So it discovers the routers, the switches, the wireless components, all of these pieces. And then from DNA Center, you can build policies to push out configuration and manage it. You can, it rolls up all operational information. And so there's a big component of DNA Center that's called assurance. And the idea behind assurance is we want to assure that the network is acting healthy, that the clients are healthy, and understand the state of the network. And so through DNA Center, we can push config, but we also get the assurance function where we can track the health and state of what's going on inside of the network. There's a concept of a health score. This actually started in I think the first place I remember it popping up was within kind of some of the data center technologies. This idea of saying we're just going to give one number that says how healthy this component or this part of the network is. And that idea of being able to say, okay, drill down all of the health and stats and all of these pieces to a single number, that's been kind of brought into the DNA assurance area as well. So you can get a client health. You can look at a wired or wireless client and it'll report in the assurance, like here's the health score for that. And it's considering things like network connectivity issues, path problems, all of the things that the network can see about the health of that product. And so that's the assurance component. So we get configuration and provisioning, we get visibility and assurance. Those are kind of the functions that the controller provides inside of the network piece. The actual data plane, where the traffic flows, doesn't ever go through the controller. So the controller is not a bottleneck for actual traffic consumption. We're still using the value of the distributed model that has been so successful in networking for years. So routing protocols, forwarding decisions, all of that is still done at the edge. It's just kind of the management plane, the reporting plane is kind of pulled up into a network controller so that makes it easier. You've got one touch point rather than hundreds of touch points for every single device in the network.
I think we could go on a whole long discussion just on DNA. But we've got someone else joining us on the next call, don't we, Hank?
We do. We're going to spend probably an entire call, if not more than one, depending on how the dialogue goes, kind of diving into the DNA architecture, understanding these components. And we're having a buddy of mine from Cisco joining up, Jason Cooley, he focuses very much kind of in the DNA space, and he'll be able to take us through all of the super details on DNA and DNA Center and assurance and all of these components that are in there. And so we'll hold off our deep conversation when we've got the super sharp expert joining us.
That's great. So did you want to, before we talk about other products, did you want to talk about the Southbound protocols that DNA uses, or should we leave that till the deep discussion?
So we can mention them quickly, but that's actually an area that we can definitely dive in deeper with Jason as it goes through, because he'll know some of the pieces that are there. But so what you mentioned, Southbound, for folks that may not be familiar with what that is, it's a when you're talking about APIs and interaction, north, south, east, and west are kind of the way that I think about them are directional capabilities from the point that you're talking about. And so a southbound interface from DNA Center is a connection from DNA Center to something that DNA Center is going to manage. A northbound connection from DNA Center opens up an interface for a different way to manage DNA Center itself. And so northbound interfaces are typically like the REST APIs that are exposed by DNA Center. Those would be northbound. Southbound is how DNA Center talks to the network components that are there. And DNA Center uses kind of a mixture of the interfaces to the network devices that are available. And so DNA Center might use CLI to talk to some components. It might use netconf to talk to other components, REST APIs to talk to other components that are there. And what DNA Center is talking to are your routers, your switches. It's talking to security components like Cisco's ICE, which is the identity service engine. That's what manages kind of access control, who's allowed to talk to what, who's allowed to get on the network. That's a component that DNA Center talks to. Wireless elements. So all of those, the southbound protocols from DNA Center is how we connect to those different devices. And like I said, it's a variety of interfaces depending on which platform is being talked to. And so we can go deeper into that with Jason if there's more interest. So,
well, that's great. So positioning of DNA enterprise, is that correct?
Yes. Yep. Enterprise. So this is your campus, your WAN, SD-WAN solutions, wireless, kind of all of that fits into the DNA bucket, the DNA Center bucket.
Great. So what about ACI and some of the others. Sorry, Hank, I don't want to, you just carry on. I don't want to keep interrupting you. Sorry.
No, that's okay. I got a bit of a dry throat today too. So if DNA and DNA Center, that's the enterprise space, let's move up into the data center. And so when Cisco talks about data center, it's probably no surprise. This is the area that's kind of a mission-specific network that's designed to house servers and storage components and application pieces. It's a data center. Like most people kind of get what that is. Some companies have data centers that are dedicated, gigantic buildings that the only thing they are is a data center. Other companies, their data center might be just a rack in the back of the headquarters, right? So data centers kind of depend on what a data center is for an organization. Depends on what type of organization it is, how big their requirements are, and inside of a data center network, the types of traffic that's needed, right? What we're looking for in a data center network is very high-speed connections into servers. Today, I would say that it tends to mean that every port connected into the data center network is probably a 10 gig port, because that's the bare minimum that servers and storage go. Though we are starting to see components come in that are connecting above 10 gigs, so 25 gig, 50 gig, 100 gig, though the 100 gig is probably more kind of between switches and connectivity components, not directly to a device, though I imagine at some point we might get there, particularly with some storage components and things. And so that brings us to the first kind of difference that we start to see between a data center network and an enterprise network. It's pretty rare that we need a 10 gig we need high density 10 gig to connect in our enterprise. We just don't need those. Workstations are still 1 gig is the common connectivity. We're starting to see some of these new multi-gig pieces, but even at that point, those tend to be for uplinks to distribution points. But a data center switch needs to be high density 10 gig at the minimum. And though we're starting to get pressure from lots of customers to start to support these newer protocols like 25 and 50 gig. And so the hardware platform that's needed, that's where the Nexus switch line fits in. So from a hardware perspective, Nexus switches are designed for the types of connectivity that are inside of a data center. So they're 10, they're 25, they're 50 gig high density switches. And then from an uplink perspective, to connect what would be either a leaf or an access switch in a data center, now we're running it at speeds of the 25, 50, 40 gig, 100 gig coming up, the uplinks from an access switch to some sort of a distribution or spine switch in the data center. And that's the Nexus hardware platform sweet spot, is providing that type of connectivity, really high throughput, no oversubscription on these switches, so that we can get kind of blazing fast speed across our data center. So that's why the Nexus platform is kind of there, different than the Catalyst platform. They're just not designed for the same types of connectivity needs that are there. And then when you're talking about how you want to configure and manage and operate inside of the data center, this is where the ACI solution potentially can come in. And so when customers are building and designing their data center and figuring out how they want to manage it, there are a couple of different approaches that different customers take. Some customers want to have kind of a commercial packaged, we'll call it the SDN solution. And from Cisco, inside of the data center, that's where ACI fits. ACI was designed to be an application-centric infrastructure. It's a product from Cisco that kind of combines the infrastructure layer, the hardware layer, which is made up of those Nexus switches, with a centralized management and operations plane that drives kind of full automation across your entire data center fabric for connecting physical switches, storage components, virtual machines, containerized workloads. Like, no matter what you want to connect into your data center fabric, ACI is kind of a single place. The ACI controllers are a single place where you can manage the physical infrastructure as well as all of the connectivity and policies that go along with those. And we've talked about ACI in a couple of videos. We've demonstrated it, particularly with some of the Kubernetes integration. And that's what ACI offers. ACI offers customers and network engineers this way to have a single place to touch manage your entire data center network in a really convenient fashion as it goes through. ACI offers integration into security components and application components like load balancers, and all of these is kind of a very packaged up commercial curated offer for data center SDN. And we've got lots of customers that want that. They just want to be able to consume something, buy it, install it, and use it. and take away some of the independent device level management that's needed. Now, we do have other customers that are more interested in maybe, rather than having a single curated model for managing all of their data center infrastructure or their data center network infrastructure, they want to be a bit more open, design their own management capabilities, and they want to be talking directly to the network devices that are out there. And they may be designing or using an open source network controller, or using DevOps strategies and DevOps tools to kind of push out configurations to the edge devices. And they're not as interested in having kind of that commercial packaged SDN controller from Cisco or anybody, but they do need hardware to run in the data center. And so that's where we get kind of ACI is for the customers deploy ACI when they want the kind of the curated packaged SDN solution, just kind of like turn it on, use it. And then if customers just want to be able to kind of have a bit more control, maybe their requirements don't fit the ACI model as well, well, then they go through and they deploy the same infrastructure, the same physical switches, the Nexus switches, but they then build their own orchestration or management layer on top of those. And so that's kind of when customers go ACI or don't go ACI, it just comes into like, where do they want their own control point to be? Do they want to consume an SDN solution, or do they want to kind of be crafting their own SDN solution at the controller management layer on that? And we've got customers that go both ways on this sometimes, depending on what types of use cases they have. If that makes sense, ask questions. Let's get, because there's a lot that's in there, and we can certainly spend some time clarifying some of those points.
Yeah, I think you did a really good thing there. How do I say it? You emphasize that there's a controller piece, but you also emphasize that there's the infrastructure piece. And some customers will take both. They just want a pre-packaged solution from a vendor like Cisco. And then some customers just want the Nexus switches, but they want their own controller. So if I understand it right, what you're kind of saying is some customers will just want the Nexus switches, which have an API. So rather than just the old day CLI, they have an API, and that's what's really good about Nexus, apart from the other things. So they could use Open Daylight or whichever controller they decide to use and talk to those APIs. But then they could just go the whole package solution where Cisco provides everything. Did I understand that right?
Yep. I think you're spot on that. And that's one of the things that's been really nice about the Nexus platform is from Cisco, it was one of the first networking platforms that really fully embraced programmability and APIs. So the Nexus switch line and the Nexus platform has got lots of different interfaces, programmable interfaces, to fit different customer requirements. There are integrations for DevOps tooling. And so the Nexus switches have got agents for Puppet. And so Puppet's a open source DevOps configuration management tool that's been heavily used by organizations to manage their server footprint and their application components. And then several years ago, actually, Puppet customers started to say, you know what, can't I manage my infrastructure the same way? Why can't I manage my network like I manage my servers using Puppet or Chef or Ansible, which are all similar types of pieces? And so the Nexus products have got agents for Puppet and Chef. Ansible support is there, but Ansible doesn't require an agent. And so that's actually a really common way that inside of the data center, folks are managing their Nexus platform. If they're not using ACI, they might be managing the switches and the configurations that are out there through one of these DevOps tools like Ansible, Puppet, or Chef that they go in. Or maybe they're writing their own custom scripts using Python and maybe a library like Napalm, where they're pushing configurations out using NX API, or any number of other creative ways. And that's one of the things that I really enjoy about being a network engineer today and exploring SDN is there's so many different ways to tackle problems, and organizations have this flexibility of choice that they can look at it and say, you know what, we're going to consume an SDN solution that's more packaged, and we're gonna integrate into it. Or, you know what, we've got some smart people, we've got some very specific requirements. We don't need a full packaged SDN solution. We just need this to work. And so we're gonna buy infrastructure, but we're gonna demand that infrastructure be programmable so that we can manage it through our own SDN kind of management controller type of a place that goes through that maybe is a combination of open source solutions and custom built code. And so we've got platforms that kind of span the entire spectrum for that. No matter what type of customer you are, Cisco wants to make sure that we've got something that fits into your expectations.
Yeah, that's great, because I mean, like, we've been saying, we've been teaching a bit about Python in these videos, and I've got Python courses, and I've told guys you need to learn Python. But I think a good point is you've said you could use Puppet or Chef or Ansible, and you can talk directly to the devices. So that's one model. Or you could talk to the APIs on the network devices, but you could also talk to the API on the controller if you want. So the controller would have like a REST API or something that you could talk to as well. Is that right?
Absolutely. Absolutely. Yeah. And that's one of the key pieces. All of the platforms from Cisco, whether we're talking about enterprise or data center, SD-WAN, controllers, service provider platforms and focus platforms, everything has APIs that are available. And you can find the details about those APIs for the platforms up on DevNet. And so I've got our DevNet site that's up, and there's a few different ways you can drive in if you're looking for the pieces. If there's a specific technology that you want to dive into, our technology menu here up at the top will let you drill through the different platforms that are there. So we're talking networking at this point. So under networking, you'll see that we've got links for sites that'll dive into DNA Center Platform, which is the API integration components from DNA Center. If Meraki, we haven't talked about Meraki yet, but we certainly can in a minute. If you're interested in ACI, we've got a site on ACI where you can drill into the programmability that's there. We've got our different physical elements. So we talked about how some customers are interested in consuming a packaged SDN solution. So that would be DNA Center or ACI or Meraki as examples. But other customers just want the components, the network infrastructure, and then they're going to do their own automation around that. And so if you're interested in iOS XE, NXOS, or XR, you can drill into those and see the APIs and resources that are available across those. We've also got a data center category. So inside of the data center, there's, in addition to the network components, there's also Cisco UCS from a compute perspective. And so you can jump in and look at the UCS management. We've also got the data center switching components in in this category as well. So NXOS, this will take us to the same place that we saw in the networking place, as well as ACI. And so if you're working with any of these platforms, you can go to DevNet to learn about the interfaces that are there. So for example, we'll go look at the DNA Center platform page. And so up on DevNet, you can learn all about DNA Center platform. We can see some of the value prop that's there, the capabilities that are available. You can see some of the solutions. But you can also jump right into kind of the documentation that are there. So we see up here in the corner, we've got Docs and Learn. If I click on Docs, this will open up and give you an ability to kind of understand the APIs that are available. So we've got API reference guide. So if you're interested in programming DNA Center platform through its APIs, excuse me, we can dive in here and you can actually see all of the API documentation. So how do you work with some network discovery that's in there? The inventory APIs that are through here. So all of those details about the platforms, whether it's DNA Center or ACI or one of the device platforms, you can find all of that information up on DevNet. And then the other thing that's really nice is, excuse me, a frog in my throat.
Do you want to take a break, Hank?
No, I'm good. I'm just trying to clear my throat. All right, there we go. So the other thing that's nice, we've got the API documentation that's here, but if you're just getting started, we've got the whole learning labs that are available. And our learning labs are designed to kind of give self-guided exploration through the different platforms that are there. So we can see we've got the programming the digital network architecture, DNA. And so inside of this learning track, we'll walk through kind of fundamentals of networking that are there. So what is SDN and all the pieces? And then we'll walk you through the different elements that are relevant inside of DNA. And so DNA has DNA Center REST APIs. So we'll walk you through some learning labs to explore those. But DNA is kind of an overall term, as we mentioned, for enterprise networking. And so maybe you're interested in working with the devices themselves through the interfaces of NetConf and Yang. And so we've got labs related to model-driven programmability where you can dive in and kind of walk yourself through and learn how Yang works, learn how NetConf and RESTConf work. And then we've got Meraki's also, again, part of the enterprise area. And so we've got labs on those. And as we've said in all the videos, all of these resources up on DevNet are completely free. And so if you want the API guides, you can find those at no cost. You can just kind of go through. If you want to take one of our learning labs or go through some of our video courses that are available, all of those are free as well. You'll see that you have to log in to take a learning lab, but the account into DevNet, 100% free. And if you already have a Cisco account because you've downloaded software, you can go ahead and log in with what we call the CCO account. That's your Cisco account. So open access to all of the material up on DevNet.
That's great. Could you go back to that networking page, Hank, where you just list all the products?
Yep, I certainly can. So it's what we had here was there's a couple of places. So the networking, we affectionately call this our mega menu because it's the place where you can drill in.
I like this, yeah.
Yep, and so this will take you through the technologies that are there. We also have, I'm trying to see, is there a link here? We have what we call our dev centers. So if I go back to our home page, down here on the main homepage, you can see jumps to different places, but we've also got dev centers designed for different portions of the platform. And so we have a networking dev center that if you're not exactly sure, you don't know which product or you don't have a specific product in mind, you can go into the networking dev center here. And so we designed this as kind of a jumping off point for networking, network programmability in general. So you can come here and say, okay, well, what are you looking for? I'm looking for information on how to program networks. I'm looking about Python specific. I'm looking for device level APIs or network controllers. And so there's a couple of different entry points to DevNet depending on kind of where you're coming from and what you think you're looking for. If it's a specific technology, really easy to find it. Go through our mega menu. If it's more generic around network programmability, the Dev Center is a great place to go as well. And we've also put together, let me see if I can remember the link for it. We've put together a specific page kind of to help people get started. What we've put together here is kind of a curated starting point for folks new to network programmability or DevNet in general. And so right from the main page, right, it was the Start Here, Start Now page. And so we can come down and we'll take you through this nice little path that you can go into. We can give you some examples of depending on where you're at. Are you learning to code? Are you interested in some of the business pieces? But for example, if I just come up here and say, okay, let's go ahead and start our journey on DevNet. It will go through. It's going to curate this and keep track of what we've completed. So it's going to want you to log in. And again, I can log in right with my Cisco ID. And I need to actually put my credentials in. There we go. So once we've logged in, it goes through and says we've curated a list of activities. So these are some suggested places to get started. And so from here, we can see that there's a handful of learning labs. So an introduction to DevNet that will walk you through some of the resources that DevNet have available, REST API fundamentals, the DNA Center APIs. And so if you are just looking for an interesting place and you don't have specific topics in mind, this Start Now page is a great place to kind of get going because it'll kind of walk you through some basics. And one thing that I've learned time and time again is that if you don't know where to start, as long as you do something fairly quickly, you'll start building up your own list of questions and topics that you want to dive deeper into. And so even if you just do a couple of the learning labs that are kind of designed here in the starting path, and then you say, you know what, now I'd love to dive deeper into this, well, then you can go explore some of the other resources that are out there and kind of go in whichever direction makes sense for you.
That's brilliant. I mean, having a Start Here page, it makes a lot of sense because if you don't know where to start, there's so much, it's overwhelming. And I think that's one of the disadvantages of DevNet is, some guys have said this, and I think just to talk to their point, there's so much, you get lost in the content. So this is brilliant to have a place where, to start with.
Yeah. Information overload is certainly a challenge that we're constantly going through because the goal of DevNet is to provide kind of the developer platform across all of Cisco solutions. And as we've been talking for our entire video today, we have a lot of solutions. And so trying to bring all that stuff together in a way that makes sense. We're actually right now going through some work inside of DevNet to try to figure out, okay, is there material that maybe doesn't make as much sense to still be highlighting, pulling out some of our older outdated learning labs and focusing in on ones that we think make more sense today for engineers and developers to take a look at. So with luck, over the next chunk of time, you'll start to see a more curated and kind of targeted approach on the DevNet site and resources to make it easier and less overwhelming with just all the material that's there.
But on the flip side, Hank, I've got to say, this is an amazing resource because typically you have to pay for information. And what Cisco have done really well here is that you're basically teaching us for free, which is great.
Well, we appreciate the feedback on that, and it's one of the things that I do love about being on the DevNet team is it gives me the opportunity just to kind of get material out there into the hands of people that want it and are interested. And there is no PO required or credit card. Enter your credit card here. It's just we've got all this stuff. Please use it and tell us what more you would want, because we've got a team of people kind of dedicated to making your life easier.